talk about Methoprene test today. So this material has been extensively used during the past decade in the United States and elsewhere. So the test on Methoprene a little bit tricky. At the rule of thumb, I like to set up the water cup and the larvae first before I make a dilution, so that you can avoid any possible contamination. But you can make your dilution first if you want to. If you can control everything in a clean way. So same as BTI or spinosad and other tests, your goal is to get a range which will result approximately 5 to 95% mortality plus your untreated control. So based on the literature and also experience, we still have 4 generations here from low to high, and including your untreated control. By nature of this material, we know it's a juvenile hormone analog. It works at a fraction of parts per billion level. So the concentration we use mostly is 0.25, and 1, and 5, and 25 parts per billion. As you can see, the range here from 0.25 to 25 is 100 times. So for BTI and spinosad and any other larvicide which kill the larvae quick, for example Tamifas, you mostly use the range like a 5-fold, I would say, maximum. But this one, first thing I want to remind you is the range is much broader. So you're gonna add 100 ml water per cup. Then the next important thing is the larvae we used. In BTI and spinosad, we're talking about using late 3rd, 4th, or you can stretch to late 4th. But these larvae, I don't know, you can take a closer shot of this. You see some pupae there. I'm not using the pupae, but the pupae tell me which stage they're at. So I can call them pupating larvae. I don't know, you can see the word from the textbook, but pupating larvae, meaning these larvae are ready to pupate. They are really, really old. Well, you cannot use this for BTI and spinosad or anything else by ingestion, because the larvae at this stage, they pretty much shut down feeding or at a very, very slow pace. They're ready to pupate. Well, why we use this kind of larvae? Based on the mode of action of a methoprene, right? It's a juvenile hormone analog. So when this time their life, their natural juvenile hormone 3 is down to a very, very low level, that's the window time for methoprene to work. If the younger larvae, if they have a lot of natural juvenile hormone in their body, it takes a lot more to change their balance. So still 25 per cup, and if you have larvae there, old larvae, that's what you want, and sometimes because you're using pupating larvae, likely you get some pupae there, and you want to remove the pupae because pupae have a thicker cuticle, so they absorb methoprene, I would say, slower than larvae. You don't want pupae in your cup. So you do the same thing for all the cups here. Then you need the larval food. Sorry. You remember when we ran the BTI test and the spinosad test early, we used 10% suspension of rabbit pellets, because this one you have to give enough food to sustain their further growth and to pupal stage, because they're not pupate yet. If you put the slurry or the suspension and the warmer temperature, you could cause the scumming problem. So the scum could kill the larvae, before methoprene does. So what I suggest is you put a small piece of rabbit pellets, do not ground up, do not suspend, just throw a little piece to it, So this piece will get swollen, get slowly released, can serve as a slow release nutrient and keep your water relatively not clear, yellowish clear, and sustain the larvae to pupation. So the food addition is different from other tests. And after this, you're going to make a treatment. That's assuming we get all the cups ready. They're ready to be treated. So we're going to talk about how we make the dilution. Because the concentration is so low, you got to be very careful. This is the dilution range I use. So you're going to start from Methoprene 0.1%. Then, of course, the 10 times dilution will be 0.01. Next will be 0.001%. The next one is 0.0001, and last is 0.00001%. Convert down. So you're going to make a dilution here, same as before, 10 times dilution. Based on the literature and our experience, you will need 5 10 times dilutions down to 0.00001%. Actually, too many zeros if you say it's 100 parts per billion, your last one. Well, how to make this one 100 parts per billion? So let's add water first, of course. Because the material we're going to use is the liquid, is a 5% methoprene. I would say is micro-encapsulated EC formulation. It's kind of milky white looking, a little sticky. So compared with solid, this in itself has a volume. So my calculation here, I need 400 microliters out of this. So that means first of all, if the total volume is 20, I have to start from 19.6. Let me breathe. I'm going to put a 10. Then I'm going to put 9.5. And then I'm short of 100 microliters. I have to make it 19.6. So I'm going to continue the other 4. Each of that will be 18 mils. I'm going to add 10 first. And then I'm going to dial back to 9. Oh, actually 8. Sorry. So it's 18. 18. I need 2 more. So now I have these 5 vials here. First one is 19.6, then second, third, fourth, and fifth one, they're 18. So I'm going to take the material. If you do your math, 5% of liquid formulation, 5% active ingredient. If you want to achieve the first one, concentration is 0.1% in 20 ml total. The amount you will need is 400 microliters. Like I said, this one's a little sticky, like a high viscosity. So you want to do a little bit slow. Make sure you're not getting air. Nice, 400 microliters. You can wash it a little bit. Because it's an EC formulation, it's pretty easy to suspend. So just some gentle agitation will make your very nice whitish suspension right here. Then the 10 times dilution is same as before, because there are 18 ml waiting there. You need to transfer 2 ml from the upper one to the lower one. Do the same thing from here down. Do the same thing 10 times. Just make sure narrow across the lids. So the last one is 100 parts per billion. As you can tell, it's just like water, you know. Doesn't look at anything there, but it's mosquito larvae, know something there. So you have this 5 here. From here to this cup, how to achieve your concentrations from 0.25, then 1, then 5, then 25 parts per billion. So you will need more than 1 dilution here to achieve this broader range. So my calculation is, for the first cup, you need 250 microliters of the last dilution. The last dilution, 100 parts per billion. You need this one for the first concentration, which is 0.25 parts per billion. You need 250 microliters. Treat like this. Well, we didn't do the whole thing. I would take hours. Well, I would take about an hour. The second one, you need the same dilution, but it's 1 ml. You don't have to change the tip because you're going from low to high. The third concentration, you need the upper one, 500 microliters. And then your last concentration here, the highest, which is 25 parts per billion, you need the upper one again in the amount of 250 microliters. So you need these three to finish your treatment. So you can verify your final parts per billion versus the parts per billion in this vial in the amount of 100 milliliter. So the setup, we ignore the difference of your added amount from here, the dilution to this. For example, the last one, you add 250 microliters of that 0.001, which is this one. Your actual volume here after the treatment is 100.25, but we consider it as 100. So there is a fraction difference. So that would be the treatment. After treatment, well, if you know the mode of action of this methoprene, any other human hormone mimic or analog, they do not kill the larvae directly. Instead, they hit the larvae during the transition from late forcing start to pupae, then to adults. They can interrupt their emergence process. Since you are using untreated control here, you have low concentration, you're going to have some adults emerge in order to have a range. Well, those adults are going to end up in air, right, in your insectary, whatever. So we use this. This is nothing different from when you go to a store, convenience store to get a drink. There's a lid on the top, Starbucks, for example. So you use the screen. I would recommend at least 12 by 12 or strings or smaller holes. This is a 144 mesh. Even smaller if you're doing Aedes aegypti. Those mosquitoes, we know their behavior is different. They're kind of tricky. Try to squeeze through the hole. So you have to cover like this. Cover them all. Just pretend you have all of them with water and larvae treatment, food, everything. So in this way, after, I would say, middle 80s, take about 5 to 6 days. What's the ending point? You don't see anything alive in the water anymore. No live larvae, no pupae, nothing. Either emerged or died or dead. They died as larvae, which is possible at a higher concentration. But most studies should die at pupal stage. We'll show you when they read the results. So you're going to have a typical setup like this. A cup with a dome, with screens patch the hole to keep the emerged, if any, adults inside. Well, you may say the inside nothing to eat, nothing will have moisture, but have water, but they cannot, there's no sugar, nothing, they're gonna die. It doesn't matter, not gonna impact your results reading. We'll explain this later on. So put your setup under 82, 84, then take about, if you're using the right age of larvae, take about 5 to 6 days to finish up. By the time you don't have survivors in the water. So we finish the setting up stage. So after you set up the test in the middle 80s, like 82 to 84 Fahrenheit temperature for 5, 6 days, you can check by day 4, day 5 around. Your cutoff point is you don't see any survivors in the water. No larvae, no pupae tumbling around, no larvae diving around. That's the time you can read the results. But remember, after your treatment, the larvae or pupae, they're under stress. Normally they go slower than untreated control. Your untreated control cups, they always finish first. A little bit scary looking. You're going to see a lot of adults buzzing inside this dome here, but very careful, don't knock it over. You'll be sorry if you do. So, then you take a quick look from the beginning, very low, and then the middle, and then the high. You should approximately see a difference of adult mosquitoes in the dome. You should see more at the lower end, you see less, if any, or very few on the high end. And you see a pattern going through this. And if you take a closer look, when you see more adult mosquitoes here, you should see more pupal skins floating on the water surface. They're corresponding to each other. So every adult mosquitoes emerge successfully, they will leave one exovie, or exovie, plural, floating on the water surface. That pupal skin, or exovie, is always split from the top of the thorax of the pupa. And if you wait too long, that pupal skin can break. You sometimes split half. If you take a closer look, it's better to half and half. Always one half is bigger than the other half. In that case, if you're traveling, you're out of the schedule, then you miss the best reading time. The pupal skin's broken. Well, as a remedy, you can read only the bigger half in order not double the numbers. But you need to take a closer look. If, let's see, so many adult mosquitoes across the board, they're probably on the lower end, your dosage is too low. If you see almost none of them in the dome, except your control, then you're probably may have to redo it. The worst will be, regardless of your treatment, you see so many dead larvae in the untreated control. Something else caused it, contamination or what. Or you see very few adults emerge from the untreated control. That's not good either. So in the fast-affecting agent, like a BTI, spinosad, for example, we try to control mortality in untreated control like a 5 or below. Actually, a lot of time you can control like a 1% or even no mortality even. But in Methoprene test, we allow the untreated control mortality up to 10%. If 10%, we won't do a correction or redo it even. Because the difference among the individuals, their internal hormone just different than their response to, just the variability is greater. So we give us a little bit more. And the plus is the extended time of observation is not 24 hours, not 48 hours. It's 5 to 7 days. So you will have a chance to have more mortality here. To give a little more flexibility, if you need, just go ahead and do the Abbott formula to correct the mortality. So when you read, how are you going to read this? Because you have adults in the dome. You have to be very careful. I will get a cage. I get a mosquito cage here. So you're going to hold this thing carefully, like this. You hold your finger for the top and grab the side, surely, nicely tight. You can move around and nothing flying out, okay. And then you put this whole thing to the cage. Just go through the sleeves, can be a pain. That's why the Methoprene test takes some time. And now you're safe, release them all. Let them go, flyers, out of the cup, out of the dome. Make sure no one. Sometimes they're standing on the water surface. It looks like they're not going to fly or dying or dead. And they're not going to fly until you take your cups out. Then you fly. And then it's too late. So from here, I'm going to read the results here. Your goal is to figure out how many dead ones. They can die as the larval stage, particularly on the high end. Some of them may not make it to the pupal stage. You say, well, I'm going to count dead larvae, then dead pupae, then some of the adults, their wings and the legs are stuck on the pupal skin. That's called the incomplete adult emergence. Also, treated as dead ones. Can be very messy looking in this cup. The easy way is not count the dead larvae, not count the dead pupae, not count the incomplete emergent adults. Just look for the pupal skin. The free one, I call the free exuvie. How many I got of this? They're clean, just one by one, intact, not broken pupal skins here. I retrieve them all. Most of them are floating, sometimes go down, but make sure I retrieve them all from this cup. So if you have, let's see, expect 10% mortality at the beginning, this 25, you should get 23 or 22 around that neighborhood pupal skins. You're going to have a couple, 3 dead ones here. And remember, do not count ones that are attached to dead or dying adults. Those ones are considered as dead. That's how you read the results. Then you flip your number. I say I got 23 pupal skins here. What's the dead ones here? Or 2. 2 are dead, 2 didn't make it. So you're going to record that 2 as the number of mortality. Okay, so you do this all. This can take you a while. The high end, when you read to this cup, can be a little easy. If you don't see anything resting on the dome or side, you can open that. It's no danger here, and you can take a look. In this cup, you should have a very few pupal skin. You have to look out for that. I saw one here. So I saw another one. So 2. And 3, that's all I have here. The other ones, either the dead adult attached to the pupal skin, like this one. Their forelegs are still attached to it, they can't get out. This one's halfway got out, body is halfway, and the abdomen still in the pupal skin. And most of that, down to the bottom, their thorax and head kind of black, and their abdomen, tail, a little lighter color. Sometimes I'm joking, I said this looks like an overcooked drumstick. So the body is dark and the tail stretch out. That's a typical picture of juvenile hormone analog mortality. And the majority of the dead ones should look like this. If you see too many dead larvae or else, it's not a typical picture of juvenile hormone analog mode of action. So you should see a good number of this dead pupae down to the bottom of the cup because they don't float after a while. You should see a bunch of this dead pupae. Okay. Then you need some time, and you finish all the readings like that. Of course, the adults, you don't worry about it. You're gonna die anyway, so you don't have to do anything. No sugar, nothing. And you finish your reading here, then you record dead ones across the concentration. Then the next thing is you want to take a look. You already have a feeling. Like I said, if too many survivors, your dose is too low. If no survivor across the board, well, dose is too high. You need to dial up or down. And then you can put your raw data, on this log property paper. If you see a nice like this, from your low to high, then you see approximately a straight line. That means a good data quality. We're going to talk about data quality control or data analysis later on. If you see the dust kind of jump around, scattered on the paper, then particularly for Methoprene, you expect a greater data variability compared with BTN and spinosad. So it's not surprising you see something like this. You may have to decide, repeat or just discard the data. Can be challenging sometimes, particularly when you are using some commercial product, for example, granules or briquette, even more difficult. So with that, we'll finish the results reading. from Methoprene.